So let me start my second major topic, detergents. Here is a layout of this, the topic we are going to discuss in the detergent. Its definition, its examples, labs, its one of its types, discovery, properties, using, its action, its structures, its types, chemical classification, which is this. We will illustrate in the further moving ahead. Its preparation, its environmental impact, raw materials, application, advantages and disadvantages, chemical composition, chemical reactions, industrial preparation, and what is the hard water effect on the detergent. As we have seen the hard water effect of the soap, here we also discuss the hard water effect on the detergent, health and the detergent, what is the effect of health on health of the detergent, and what is the effect on the environment of the detergent, environmental effects, what should be for the detergent, and the manufacturing of the detergent in explanation. So, what is basically the detergent? First of all, its definition. Detergent are the sodium salt of sulfonic acid. It is basically the mixture of the surfactant with a cleaning property in a dilute solution. Detergent is a cleansing agent, but it is more effective than the soap. It has the same use as it as a soap has, but due to being a synthetic substance, it is different from soap and it has vast cleansing action rather than soap. What are the principal groups of the detergent? There are four basically principal groups of the synthetic detergent, which is surfactants, builders, bleaching agents, and additives. Now let me talk about the history of the detergent. The first synthetic the first synthetic detergent synthesized by the detergent were derived from the fat, which is formed by the reduction of the fat with hydrogen. After the reduction, the reaction was followed by the sulfuric acid, which is known as sulfonation, and then the neutralization. The first detergent was formed, and its name was sodium lauryl sulfate. The process was found too expensive. Within a few years, cheap synthetic detergents were produced from the petroleum. Lab. It is a type of the detergent and its acronym. It is an acronym of the linear alkyl benzene. Now, I'm going to talk about the structure of the detergent. This is you can see that this is the soap molecule. Yes, the both structure are same, but there's a little bit difference in the cleaning reaction. You may come to know that after this. Structure of the detergents. This is the same structure of the soap. This is the hydrophilic group, which is water-loving head, long hydrocarbon chain or long hydrocarbon tail, hydrophilic group, and water-hating tail. What are the properties of the detergent? It can act as a wetting agent. It can act as an emulsifying agent. These are the properties of this detergent. As a wetting agent, a detergent reduces surface tension of the water. As a result, the water spreads over the surface and wet it more easily rather than before it. A detergent thus acts as a wetting agent. A detergent increases the wetting power of the water. The tap water doesn't wet these clothes. Here we can see this is the clothes, and the tap water, it is a droplet of the tap water. It doesn't wet it, but when the detergent solution is added on the surface of this cloth, it wet it because it acts as a wetting agent, which lowers the surface tension of the water and help it spread it more easily than the tap. Then it acts as a emulsifying agent. First of all, I would like to tell you what is emulsifier. Emulsifier is such a compound which separates the oil out and thus cause an emulsion. And emulsion is basically is when occurs when the two substances are mixed, which are normally can't mix well, and that make a emulsion. So detergent makes can act as an emulsifying agent. Oil and water don't mix well, as we know that because one is polar and the other one is polar and the other one is non-polar, and we know that the principle like dissolves like non-polar dissolve in non-polar and the polar dissolve in polar, and oil water emulsion is unstable. Unsteadying the tiny oil droplets rapidly join together and grow large to form the separately oil layer. Here we can see that this is the water and this is the oil layer. When the detergent molecule is entered into the the that part which is easily dissolved into the oil, lipophilic part, is dissolved into the oil, and that part which is merely dissolved in the water is dissolved into the water. And then the micelle formation occurs, and it takes the oil droplet into the inner side of the micelles. Here we see the negative side of the non of the iron part of the micelle. Actually, this one micelle molecule and this is the other micelle molecule. These both repel each other, and it has an oil droplet inside it. What are the uses of the detergent? We use detergent in our daily routine life. It is also used in other products: toothpaste, shampoos, soap, body lotions, face cleansing lotion, washing powder, car wash, dishwashing liquid. These are the uses of the detergents. And here is the chemical composition of the detergent. It has two parts, same like the soap molecule: hydrophobic part and the hydrophilic part. Hydrophobic part is the non-polar part and it is water repellent part. It consists of long chain or rings and form the tail of the detergent. Hydrophilic is polar and it is water attracting part. It consists of small ionic group, and small ionic group may be sulfonates and sulfates, and it forms the detergent head. So I'm moving towards the structure. There are so many types of structures, but to illustrate the micelle formation, I have drawn here. This is the water molecule, which is attracted by the short ionic part of the micelles, and inside it there is a trapped grease molecule. The non-polar end of the molecule at the center are attracted to the circular non-material. The negatively charged group on the surface are attracted by the water molecules. Here are the example of the detergent. This is the sodium p-didosyl benzyl sulfate, and this is the sodium lauryl sulfate, sodium and dodecyl sulfate. These are the structure, but when we come to know the actual structure, these structures may seem like this. This is the long chain hydrocarbon and this is the ionic part. This is the long hydrocarbon chain and this is the ionic part. And now I'm going to talk about the chemical reaction in which we prepare this detergent. What actually happened? First, the long chain alcohol is sulfonated with the sulfuric acid, and this process is called sulfonation. After this, we obtain a product, and which goes the neutralization reaction with the base sodium hydroxide, and we obtain our desired product, detergent. Here is the N. If we replace the N with the 10, number of 10, we will gets lauryl alcohol, and this is how we obtain a raw sodium lauryl sulfate detergent. This is the cleansing action of the detergent. Detergents are the cleaning agents and they work by reducing the surface tension of the water to easily wet the surface so that it can emulsify the grease. This is the first step in which this is the surface. The whole is a third particle which contain a grease. These are the detergent molecule and the solution is the water. These are detergent anion. The next, we will come to know what is detergent anion. It is a type of detergent. In the classification, I will tell you this. So here is the cleansing action. The detergent enter into the water to wet the object thoroughly. In the next step, we will come to know that the non-ionic part, the long hydrogen hydrocarbon chain attracted by the third particles and the grease. It is get together and clumped over this grease particle. And in the third step, we will see that it's starting over uplifting the grease molecule by getting together over there. It is attracted, as we know that it has negative charge. It is strongly attracted by the water molecule, and water molecule lift it up. And this is how it is moved from the surface and formed a missile. And this entrap a grease, the tiny grease. And this has a negative charge which is attracted by the water and water uplifts it. And with the water, this is removed easily. Now I'm going to talk about the hard water effect on the detergent. Hard water, as we know, that contain calcium and magnesium compounds, and the examples are magnesium hydrogen carbonate, it formalizes this, calcium hydroxide carbonate, magnesium sulfate, calcium sulfate. What are the explanation of the hard water effect on the detergent is this. As we know that in the soap, when soap molecule is dissolved into the water, hard water, it forms a scum formation. But in detergent, we see that it doesn't form a scum formation, and let me tell you what is the reason behind this. Detergent molecules have a long chain of hydrocarbon, as we know that, but at the end, there is a sulfate group. So the hard water doesn't affect its cleansing action because they are soluble in hard water. This is the main reason, because this is how the hard water doesn't affect the cleansing action of the detergent and doesn't form the scum. Scum, scum is the insoluble curd we see when the soap molecule doesn't dissolve itself in the hard water. Now I'm gonna tell you the raw materials of the detergent. I have found the few percentage of the raw material I have written here. First are the surfactant, acid, alkali, plasticizers, ammonia, detergent filler, fat, binders, water, enzyme, bleaches, emulsifier, rinse agent, film remover, fragrance causing agent, dyes and pigments, glycerin, builder and boosters, dry cleaning fluid, conditioning agent, lime, and rust remover. Now, I'm going to tell you the explanation of the raw material, why we are using such raw material in the formation of this detergent. As we know that every ingredient imparts different properties and functioning. We use different kinds of raw material to obtain or desired raw material. In this manufacturing of the detergent, bleaches, boosters, fillers, and builders are laundry detergent cleaning agents that are added just because to enhance the effectiveness of the laundry detergent and help to remove the stubborn stain. This is the reason why we're using such raw materials to increase the efficiency of the laundry detergent and to help to remove the stubborn stain which can't be removed easily. But we also have a disadvantages over here. The laundry detergents increase the risk of the damaging of the soil. It damages the soil in such a way that the soil becomes colorless and soluble particles. Now I'm moving towards the classification of the detergent. It is or the types of detergent. It is basically divided into three classes: anionic, cationic, and deuterionic or non-ionic. In anionic detergents, the example is the typical anionic detergent is alkyl benzene sulfonate. Alkyl benzene is a lipophilic and sulfonate is a hydrophilic. These are the structures of the anionic detergent. I've told you in the cleaning agent that I will tell you the anionic detergent and its structure are this is one, second, and third. And cationic detergent. It is also similar to the anionic one, but the main difference from the anionic to cationic is the quaternary amine is used. It has positive charge. This is how it is named as cationic detergent. And the examples are this is the ammonia, which bear a positive charge. This is the methyl group surrounded by the nitrogen, and this is also a methyl group, and this is the bromine molecule, and its name is acetyl trimethyl ammonium bromide. When the chlorine molecule is attached with it, we named it acetyl trimethyl ammonium chloride. Zwitter ionic detergent. Its another name is non-ionic. It is named as because the net charge is zero, means it has equal amount of charges. And its example is chaff. The structure of chaff is this. We may see that it has positive charge and the negative charge too. And this is the name of the chaff. Now, what are the types of the detergents? Soapless detergent and soapy detergent. Now, I'm going to tell you the advantages of this detergent. They are soluble in hard water. As we know that soap doesn't dissolve itself in the hard water. This was the hard disadvantages of the soap and advantages of the detergent here. They are available in powder form and concentrated solution. They are commonly used in making shampoos and products for the cleaning cloths. They have stronger cleaning action than the soap, as it can easily dissolve in the hard water. Since the detergents are the salts of strong acid, they don't decompose in the acidic medium. But when, as we know that this is also the disadvantages of the soap because it doesn't dissolve itself in the acidic medium. As detergents are derived from the petroleum, they save uh, natural vegetable oil and are important for the essential cooking medium. Now, what are the disadvantages of the detergent? Many detergents are resistant to the action of biological agents. Biological agents are here the microorganism, bacteria, etc. And the disadvantages of the detergent is it is non-biodegradable. It can't be degraded, it can't be decomposed by the microorganisms. Their elimination from the municipal wastewater by using treatment is a problem creating fuss for all of us. It is a very arising issue. They tend to inhibit oxidation of the organic substance present in the wastewater because they form a sort of envelope around them. Now moving toward the industrial preparation of the detergent. There are basically three different methods through which we can prepare the detergent. The first one is spray drying process, second is agglomeration process, and the third one is dry mixing process. I have mentioned merely one process because it's enough to make the detergent, which is dry process. This is the machinery used for the making of the soap. In the first step, the dry material and the liquid material are combined into the slurry or a thick suspension tank, which is called crusher. In the second step, the slurry is heated and then the whole material is pumped into another chamber through the nozzle under high pressure to produce a small droplets. These droplets fall through a current hot air, forming a hollow granule as they dry. In the third step, these come into this chamber and the dry granules are collected from the bottom of the spray tower. They are screened here to achieve uniform size. In the fourth step, after the granules are cooled, heat sensitive ingredients are present there, which are not compatible with the dry heat temperature, such as bleach or enzyme or fragrance, are added here. And in the fifth step, the final product obtained, detergent, and the packaging of the detergent occur. This is the industrial preparation of the soap.